Hi students, welcome to our video on 10.4 Choosing Appropriate Measures. Our learning target today is I can determine which measures of center and variation best describe a data set. So a measure of center was mean, median, or mode. Those were all measures of center. Then we also have measures of variation. The measures of variation that we learned about were range, but there's also something called mean absolute deviation, which is something we didn't actually learn about. That was in 9.5, but it was just another way to find out how much something varies from the actual measure of center. For this lesson, you won't need to know how to find the mean absolute deviation, which we called MAD, so mean absolute deviation. You'll just need to know that is a measure of variation, but not how to find it. So to choose appropriate measures, the mean absolute deviation uses the mean in its calculation. So when the data is symmetric, you use the mean to find the center, and you use the mean absolute deviation to find how much it varies. You use the interquartile range and the median when the data is skewed. So remember, skewed left or right. So basically, if it's skewed, you would want to use the median. If it was symmetrical, you would want to use the mean. And if it was skewed and you were looking for the variation, you would want to use the interquartile range, which we did learn about in 9.4, or you would want to use the mean absolute deviation if it was symmetrical. So for this lesson, we're pretty much just identifying which variations and which centers we would use. So example 1 says the frequency table shows the number of states that border each state in the United States. What are the most appropriate measures to describe the center and the variation? So for this one, we will need to make a histogram. So we can either do it up here or we can do it down here. I'm going to do it up here because I have room up here. So we'll draw our y-axis and our x-axis. Y is always called frequency, and x is going to be called bordering states. Okay, then we'll put in our intervals, 0 to 1, 2 to 3, 4 to 5, 6 to 7, and 8 to 9. And it looks like the most we get for frequency is 21, so I'm going to go and count by 2. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, and then right there would be 21. So we'll label those. Okay, now we are going to make our histogram. So from 0 to 1 states, there are 3 of those. So right about there. 2 to 3 states, there are 13. So right about here. 4 to 5 states, there are 21. 6 to 7, there are 11. And 8 to 9, there are 2. Okay, so now we need to find out what are the most appropriate measures to describe the center and variation. So we have to decide, is this symmetrical or is it skewed? So if we look right down the middle, put our pen right in the middle, it looks like the left and right side are pretty much identical. They're off by just a little bit, but not too much. So this is symmetrical, which means that if we look over here, we would use the mean to describe the center and the MAD to describe the variation. So we would say mean and MAD. Mean and MAD. That's how I get sometimes. All right, example 2. The dot plot shows the average number of hours students in a class sleep each night. Describe the center and the variation of the data set. So first we need to figure out what if it's symmetrical or not. And it looks like, if I look at most of my data and put my pen there, it looks like we have a tail going off to the left, which means this is skewed left. So that means we are going to find the median to describe the center and the interquartile range to describe the variation. So we need to find those because it doesn't just say which are the most appropriate, it actually says describe them. So we need to find what they are. So we're going to list out our numbers. So we have 6 first, then it looks like 6.5, 7, 2 7.5s, 2 8s, 3 8.5s. Oh boy. 5 9s, 3 9.5s. Oh, I hope I have room. And 1 10. Oh, nice. All right, so since the best measure of center for this is the median, that means I need to find the middle number. So I'm going to count and see how many I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. All right, since my data is odd, that means there will be one exact middle number. So I'll start from the outside, work my way in one at a time, being very careful. All right, so it looks like our median is 8.5. So now we need to find the interquartile range, which means we're going to find the middle number of the lower half, the middle number of the upper half, and then subtract them. So cover up my last two of the lower half, work my way in, and it looks like I get 7.5 as my quartile 1. Then the upper half, it looks like I have 9 as my upper half. That's quartile 3. So to find the interquartile range, we are going to do 9 minus 7.5, which when you plug that into a calculator, you get 1.5. So our interquartile, oh, Grimm's saying hi. I don't know if you can hear him. So our interquartile range is 1.5. So that is the gist of 10.4, choosing appropriate measures. Basically, you are supposed to be able to just identify how should you find the center based off of the shape of the distribution. And then in some cases, you'll be asked to actually find the center and the variation. So that's what we did in example 2. Since I'm not here, obviously I can't help a lot during the assignment, but make sure you ask questions. You can use each other to help. And if there are some that you guys are completely stumped on, I can help you when I return, hopefully tomorrow. Yeah, and you can also email me if you need to, and I will try to get back to you. All right, you guys have a great day. Bye.